All right, why don't we go ahead and get things started. So my name is Casey Decio, and I work for VeriSign Labs, and today we're going to talk about DNSSEC. We're actually going to use, well, first of all, this is just a reminder about the preparation, but I've already said that several times. So last check for the link there, that's dnsviz.net/demo, and there's a link to the image and the other information you'll need there. So the objective today, as part of this tutorial, is to understand the basics of DNS and DNSSEC. We're going to use several tools along the way, dig, bind, and DNSViz. You may be familiar with some of these. If not, I hope this makes you more familiar with them, and I hope you can find some way to use them. And I hope that some of the other takeaways is you'll be able to find a way where you might understand these protocols a little bit better, and also learn how you might be able to use them in your environment to routinely analyze and monitor your DNS health, or to deploy DNS or DNSSEC if you haven't done so. Okay, so, and just so you know the range of this is actually designed to be from the novice level to maybe the more advanced level in terms of things, even for the advanced folks, maybe discovering some things that you hadn't known before. So I do want you to feel comfortable in here. If you're not sure, feel free to stay. I think it should be okay for you. And a lot of the exercises here, many of them are copy and paste. And so it should be straightforward, and hopefully you'll be able to keep up with things here. I should also point out that although we're going through these exercises, and you may end up using some of these tools in your environment, that these are more to the exercises we're doing today are more to facilitate understanding than they are to actually take and apply immediately in your environment. And so you need to understand, how you might take and design those. This is kind of a disclaimer. And so we're not covering all the details for proper DNS and DNSSEC maintenance in here, but also happy to answer any questions after the fact. Certainly there are other resources as well. Okay, so the way this is outlined, and I don't, we're going to start with a little bit of a DNS overview, followed by a DNSSEC overview. Okay, and then we'll go through some of the tools, DNSViz in particular, we'll go over a little bit later, and then talk about how it can be used a little bit to monitor your DNS health. Okay, so let's start out with the DNS overview. At the very basic level, the DNS namespace is something that's organized hierarchically. So we talk about the DNS root as being the top of your namespace. It's the starting point for DNS resolution. You're always starting at the top and then following referrals downwards. Let's see, zones are autonomously managed pieces of DNS namespace. And we call this, when you have one namespace with something below it, child namespace, we call that delegation. Okay, and then in terms of name resolution, you typically have three roles of clients and server roles, I guess. Stub resolver, which is something that would be on your machine, your end user machine, okay, your laptop or desktop or whatever type of computer. And then you have a recursive resolver to which you would send a query, in this case for example.com. And the query has a name and a type, and you are going to, your recursive resolver is going to do some extra work. It's going to start at the root, assuming it has nothing in its cache. It has no memory of what it's done before. It's going to receive a referral downward to the COM name servers, ask the same question. COM is going to send it back a referral to the example.com name servers, and finally, upon asking the example.com name servers, the recursive resolver will receive a response and send it back to the stub resolver, and finally you can go on your merry way and do whatever it is you wanted to do with that IP address that you were looking up. Okay? So that is my two-slide intro to DNS. Okay, and that's all we're really doing, but now we're going to actually look at some of that. So if you haven't already, please go ahead and start up your VMs, and go ahead and enlarge the screen so it's useful. So you can have enough real estate to move around there. And then on the screen in kind of the lower left-hand side, there should be something there that says tutorial exercises. And and just to get prepped here, I'd like you to open a terminal window and then change directory to the demo directory. Okay, so you should be in demo at that point. Any problems starting the virtual machine? Okay. I'm going to move along, and I'm going to kind of, as we go through the other, this is the easy exercise. When we go a little bit further along, I'm going to just kind of keep on eyes and maybe ask for signals along the way, because I do want you to have enough time to complete the exercises, but I also want to keep an eye on the time so that we're able to get through the entire tutorial here so that it's useful for everyone in the room. So I hope this to be somewhat interactive, and if you do have questions along the way, please let me know. Okay, so within your environment, you should now have a terminal open. You should be in the demo directory, and you should also have the tutorial exercises open in some type of a text editor just so you can refer to them. Those will stay open throughout the entire thing because you're going to be copying and pasting exercises into terminal windows. Okay? All right, first thing we're going to do is we're going to practice some of this DNS resolution manually. So exercises 1.1 through 1.5, if you would like to join with us, are the following. We're going to issue queries to root servers. Okay, and again, all these exercises are in your window, so you shouldn't have to type these out. You can copy and paste these from your exercises.txt directly into your window. You'll notice in the exercises after each one, there are some questions about it. So when you get done, I'd like you to take a look at those. And some of you may be more familiar and you say, okay, get to the hard stuff, that's fine. But again, this is the part for everyone to get a little bit of understanding along the way. Okay, so go ahead and query all those, do all those exercises 1.1 through 1.5. I'll give you about a minute or two to do that, and then I will go through some of the results of what you should be seeing and give you a few insights into what you're seeing. I need some background music playing or something. So again, once you've executed these queries, I'd like you to just take a look, maybe answer some of the sample questions that are in your exercises.txt. I guess it's tutorial exercises.txt, but you know what I mean. All right, I'm going to go to the next slide here. If you're still working, that's okay, but I'm just going to show you what kind of things that I'm looking at when I'm seeing this initial query to the root. I mentioned the referral process that happens when you're issuing that query to the root server. Remember, that's the very top of the hierarchy, and you're asking the top for example.com. It doesn't know the answer, but it does know how to get to .com, and the way it does that is through this authority section in the response. So you're seeing this on the left-hand side of this response com, and you're seeing on the right-hand side all the servers, the names of the servers that correspond to .com. One other thing you'll note that's highlighted on my slide up here is that in the flag section, you don't see any authoritative answer bit. You do see this RD bit set, which means that I had sent that dig by default sets this saying, do recursion, go find the answer for me, but there's no recursion available because the server isn't going to go find the answer, it's simply giving you a referral instead. Okay, if we go to the next one where you've issued the query to the .com servers, you're also getting a referral. Again, if you look in the authority section, again, you're getting not an answer. Yes, you have a question. I'm going to stop. Yes? Okay, so the question was about whether the recursion no in the bind configuration is why we're getting that answer. So you're talking about the bind, the name server configuration on the far end, the server we're communicating with, in that case, this case, the GTLD server that we have just queried. Is that correct? Yes, so it would have something like that saying, yeah, we're not going to do recursion on the other end. Now, what we've hit may not be a bind server, and in this case, it's not. Actually, I don't know which server. Yeah, it is not a bind server, but the idea is there, yes, that it's configured to not do recursion. Therefore, it's not going to get you the answer. It is simply sending you a referral. Yeah. Okay. Thank you for the question. All right. So this is very similar to what we saw with root, but we're being referred to example.com. And again, you see there is no recursion available flag or authoritative answer flag. We'll go to the final one here where you queried the example.com server, and now you see there's still no recursion available because we're not asking it to go find the answer. We're simply asking if it has the answer, or that's what we're hoping, I should say. And it does actually send us an answer this time. We get example.com, we see the IP address there, and we've effectively now done what a recursive server would do in a very simplified fashion. Okay. All right. So the last exercise in this section was to query a local recursive resolver, and in this case, because we didn't specify which one, it's looking in your resolve.conf for whatever your default is. Okay, so, and in this case, it's actually a recursive server that's running on your virtual machine. So when you say dig example.com, you can see at the very bottom, what's highlighted on the bottom of my slide there, it tells you the server that it's coming from, in this case 127.0.0.1. And then you can see that the RA flag is set at the top, what's highlighted in the top there, which means that recursion was available and it actually did go do the recursion for you. Okay, it found the answer. So it did all what we did in those previous 3 steps, but it did it for you. All right. And then we're also going to look for that, I guess this wasn't the last one. There's one more here where we now are queried for a non-existent name. So we issued the query to that example.com server, and in this case the name did not exist, and we got simply an SOA record. Among other things, this SOA record tells us how long to, for the recursive resolver that's making the query, to cache the fact, or to remember that there was no such name. Okay. All right, any questions on the DNS overview? We'll get into more meaty stuff, but again, we're kind of establishing a baseline here. All right, we're going to go on to DNSSEC. So, to describe DNSSEC in a nutshell, this is our one-slide review of public key crypto. So we have a public key, which is advertised to everyone. We have a private key that is kept hidden. And now we're going to make signatures. The signatures are made with the private key, and they are validated with the public key. Okay? And then so basically we need to find some way in the DNS to give everyone our public key so that they can now validate the signatures that we have made with our private key. And so the way that is done is using what are called DNS key resource records. So we typically think, when we think in the DNS, oftentimes we think of address records. You know, you just map a name to an address, and those are common, but there are other record types. In this case, you're looking for a name with a record type of DNS key, and so you're going to query that, and it will give you the public key, actually a set of public keys, which I'll show you in just a moment. And it will also give you signatures accompanying your record. So if we revisit this model of the stub resolver, the recursive validating resolver, and the authoritative server, you look in the query now, when we asked the authoritative server for example.com and the record of type A, we now get a response, but we also get a signature in the form of an RRSIG record along with that answer. The recursive resolver then needs to make a subsequent query, or it may have done it beforehand, but the important point is it needs the DNS key record that goes along with that signature to be able to validate the response. So now having the answer, the signature, and the public key, it can say, yes, this is valid, or no, this is not valid. In the case of valid, the recursive server also sets the AD flag in the response, saying that this is authenticated data. And in our model here, the one that's shown on the screen anyway, their stub resolver can look at that and simply say, okay, I trust that you have done the validation for me. In more complex models, you might have the stub resolver also doing that, but for our purposes today, that will suffice. Okay, so in DNSSEC, we have a notion of a chain of trust. So not only do we look at that answer, that it was valid, we have to know that the key with which we validated the signature is also authentic. And so the way that works, since we talked about the DNS namespace as being a hierarchy, we can do that hierarchically by utilizing the parent so that we all eventually, if you do that recursively, it all goes back up to a single root. So let's take this example that we have in front of us here. We have example.com, and there's some data in there, like the address records associated with example.com. These are signed with a key, and you see the public key associated with that as a DNS key record. Additionally, for the DNS key record, you take a hash of that DNS key record, and you form a new record called a DS record that doesn't go in the child, it goes in the parent. Okay, so if you look over here, that DS, you see the arrow pointing down to the DNS key. That is a hash, essentially, of the DNS key. And then the same thing happens in .com and so forth. And in the end, how many roots are there? There's one root, because it all goes up to the top. So you only need, in your recursive resolver, one key to store to be able to look at the entire DNS and authenticate everything below if you have that chain of trust. So now that I've said how simple it was, you just have a key and then a DS record above. The truth is that oftentimes you'll have multiple keys. Okay, and they'll have different roles. So one key will essentially authenticate the other key, which will authenticate the zone data underneath, the address records and so forth. And these when you split roles, typically the two roles are key signing key and zone signing key. Okay, the key signing key signs just the DNS key RR set, so it's authenticating just the keys, and that is also the one that you take the hash of to put as a DS record in the parent. Okay, and then the zone signing key signs the rest of the zone. And typically that's done for a little bit more agility in changing out the zone signing key, the lower one, because you don't have to interact and change that parent, modify anything in the parent, which may not be under your control when you're doing DNSSEC. Okay, now you guys are going to have a chance to do this, so if you don't understand it, don't worry, because we're going to do it. All right, and then last thing I'll cover here is on DNSSEC before we do some testing is authenticated denial of existence. So how do you prove something doesn't exist? Remember we asked for foobar.example.com and we came back and it said no, it wasn't there. Well, how do you know that that was a valid response, that it really wasn't there? Well, in DNSSEC, the way that they do it is they take all the names in a zone and they order them. Think alphabetical. And then when you ask for something, it looks at this alphabetical ordering and it says, okay, there's this record called an NSEC record, and it has a name, and then it has whatever the next name is. So you've effectively created this chain. Okay, in our example here, we have example.com followed by apple and banana and grape. So A, B, and G. And we've asked for coconut. Well, it looks it up. There is no coconut, but coconut falls between apple and banana. So it's going to send the record back saying, some of you are giving me funny looks. It's because C comes after B in the alphabet we're using today. So it's going to send back the record. It falls between banana and grape. So it's going to send back the NSEC record corresponding to banana, which says, we know that it's not here because if it were, it would have fallen between banana and grape. So now the validating resolver can actually validate this because it says, okay, I have this chain, it would have been here if it existed, and it's signed, you have the signatures to go along with it. Okay, so that's what we call authenticated denial of existence, proving that it's not there by sending the chain links essentially of where it would have been if it did exist. We're not going to go through NSEC 3 today. For some of you may have heard of that. That's basically a chain of hashes rather than a chain of names. But for our purposes today, we're just going to talk about NSEC. Okay, so finally, the last point here is insecure delegations. As you know, DNSSEC isn't just deployed universally. It doesn't just happen, now it's signed, now it's not, now it's signed. So there has to be a way to make it so that it can be deployed incrementally. And so the way it works is using those NSEC records that we just talked about to prove that there is no DS record. So effectively, if you're looking at this example here for example.com, you're working your way down the chain, and you were to get this negative response at some point. Now it's a proof that the chain securely terminates and that you can't find any authentication below that level of the records that you're getting. Does that make sense? Okay, so you're proving non-existence of a DS record in a parent, which means it doesn't know anything else in terms of authentication below that. All right, oh, I do have something on NSEC 3. I'm not sure how that got in here, but we're not going to talk about it today. Some of my hidden slides showed up when I put this to PDF, I guess. All right, let's go ahead and now, so we can try some of this out before I bore you too much with this DNSSEC stuff. And we're going to query for DNSSEC records. Okay, so I'm going to set you loose on exercises 2.1 through 2.5. I'd like you to run these queries. They look very similar to the ones you just ran, except we're adding a new option, this plus DNSSEC. The plus multi that is on here, that's really just to present things in a little bit more readable format because you'll notice that there are very long lines in your responses. Okay, and so, but I encourage you to use that just so it's a little bit more readable. Okay, so please go through those next couple exercises here, and then I will review some of the results on the screen after you've had a couple minutes to do them. If you have questions along the way, please raise your hand. So I will just, while you're doing that, I'll explain what we're doing. We are going to query the example.com servers only. We're not going through the entire referral process, but you're going to get the example.com address records, as you did before, but they're going this time to come with the RR-SIGs. That's what that DNSSEC flag to dig says. Bring me back the RR-SIGs also. And then you're going to query example.com again, but this time you're looking for the DNS key set. Then finally, you're going to query for the example.com DS record, which is in its parent. That is in the .com zone. The bottom two are about querying a resolver, your local resolver for the same records. So it's going to do the dirty work for you. When you've done this, please go ahead and look at the questions associated with it. See if you can look for some of the things that they are asking about in the exercises. If you have questions at any time, feel free to raise your hand. Feel free to give me a thumbs up if you're doing okay on the exercises. If you've completed 2.1 through 2.5, just so I know we're okay. Halfway there? Okay. No worries. Just want to get a feeling for where things are at. We've got another couple minutes. Everyone able to copy and paste the exercises okay within the virtual environment? Okay. I was hoping that would save some time so you weren't doing typos there along the way, and as I might do if I were doing this. All right, another minute or so. Maybe another signal how people are doing. Thumbs up if you're done. Anyone need more time? Don't be shy. Okay, let's move along then. So as you can see from the screen up here, just gonna show you what we're looking at in this output. So when we did the initial query for the example.com record, address record, okay, you're going to see down here the address record that we had gotten previously, okay, that 93.184. Down below it you have the signature, which I've highlighted the RR sig there so you can see. You can see immediately after that there's an A. That means that it's signing the record of type A, so you know what it corresponds to. Okay, and A is 8 that immediately follows that corresponds to the algorithm, the cryptographic algorithm that was used to sign it. Okay, that's just something to help determine which key was used, and of course which algorithm is used to check the signature. Okay, and you can see a couple other things that I have highlighted there. You see a date, 2016-2/12, blah blah blah. Okay, that is the expiration date for the signature. So they have a limited lifetime. What does that mean for you all that have run DNS zones forever without signing them, and now you want to deploy DNSSEC, and you've never made a change to your zone before in your life since you set it up, and now you're deploying DNSSEC? What does this mean? You need to periodically re-sign. You have to do some more maintenance than you previously did. Okay, so because if not, it'll expire. You could have let your zone go for 10 years before without expiring, just because whoever changed your or without touching it, I should say, because you never changed that address that name was pointing to. But now with DNSSEC, it adds a new element there that signature will expire if not changed. Okay, we'll show you some of that a little bit later on. Finally, if you look over to the right, that 2718 corresponds to a key tag. It's kind of like a little checksum, if you will, of a key, an ID for a key, so you can match it up and figure out which key in the set actually made that signature. Okay, so now let's go to the next one here. This is when we queried for the DNS key. You see a bunch of stuff. But now you have the keys, right? So you can tell whether that signature that we saw on the previous slide validated, right? Anyone can tell if this cryptographically validated properly? I hope not. You can't, right? I mean, okay, the trick question. But you can see now there's a few things that you can see in this output. You can see the DNS key type there. You can see the flags associated with it, that 257 are the flags, okay? And then you can see the key ID down in the, highlighted on the bottom there. You can see key ID 31406 and key ID 2718, for example. You might have gotten something similar in yours unless they've changed the keys since I did this example. Okay, so how many keys were in this response? Any way to tell? It looks like a bunch of nonsense, so it's it's a little bit hard to tell. But basically, after your, if you look, you see the name, Okay, in the answer section, you see the time to live, 3600. You see the class type, and then you'll see the type. So if you see the first two are type DNS key, and then after that, you start seeing signatures. In this case, I just see a single signature in my output. Okay, so you have two keys and one signature over those keys. And if you look down there, the signature was made, I don't have it highlighted, but the signature was made by key 31406 over on the right-hand side of that blob. Okay, all right, but that's your output for that. And now we see the DS keys, DS record, which again, these are a hash of the DNS key. How many DS records do we see? You see a DS records and then you see a signature. So how many DS records do we have? 6, I hear. Good. Okay. But if you notice, they almost look like they come in pairs, right? Because you have DS and then you have another value there. Okay, well, 3 more values after that. So DS, that next value is the key tag. Okay, so remember we had 2 keys that we saw in the previous slide. Okay, you had 2 different values there. And now if you're looking at these, you actually have kind of pairs. And you have 3 pairs, and each one corresponds to a different, each pair corresponds to a different key. So you have 31589, 43547, and 31406. Turns out only one of those was on the key set that we saw earlier. This gets a little hard to match up, doesn't it? Kind of remembering all these values and what you're looking for. Well, we're going to make this a little bit easier, so bear with me here. If you're getting overwhelmed by this, don't worry. The point of this is to make things a little bit easier. Okay, this output here that you're seeing on this slide, it was what you should have gotten if you queried the recursive resolver. That is, you weren't actually pointing to anywhere specifically, you were pointing to your local resolver. And the one thing I'll point out here is that you have the AD flag set in the flags. And so with that value, you're seeing that the resolver actually took the time to validate things. It went through that entire chain of trust. And then our negative proof using the NSEC records. Again, this was sent by your recursive resolver as well. You can see the NSEC record here. We asked for foobar.example.com. We get an NSEC record saying that it wasn't between example.com and www.example.com. Okay? All right, let's move along to something that will help. Any questions up to that point? Okay, let's make things a little bit easier, and we're going to introduce DNSViz, which is software designed to help understand DNSSEC a little bit better. Okay, so just to give you an overview of some of the tools, these are and some of you might be familiar with DNSViz, maybe the web interface. We're using the installed command line tools during this tutorial. So DNSViz has several subcommands, and one of them is probe, which if you use DNSViz probe, it will go out to authoritative servers or recursive servers, issue the necessary queries it needs to analyze the entire chain of trust and give you some type of assessment of that. Okay, and it'll put it in a serialized JSON output. Okay, it'll do IPv4, IPv6, it'll do UDP, TCP, it'll do some special diagnostics along the way. Okay, and that's DNSViz probe. DNSViz grok takes the probe analysis that you got, this output.json in this example, and it will start looking at things like whether there were timeouts accessing a server, no response back, network errors. It'll look for fragmentation problems, okay, a number of different diagnostics. It'll also do this matching between signatures and keys and DS records and keys, things that were a little bit difficult to do without that. Okay, it'll certainly look for expiration problems with your signatures. It'll look for problems with your hashes, okay, and so forth. Now, and then graph does the exact same thing as grok, except for instead of outputting it to a JSON output, for a serialized JSON output for programmatic analysis, it does it to a graphical output. So you can do it for JPEG, PNG, or HTML formats. And then finally, DNSViz print has a terminal format. If you're running this on some type of environment, how are you going to get this, graphical environment to some place where you can actually use it? Print is kind of a shortcut to to actually put it out to a terminal output and show you some of that same information. It all uses the same engine to show this information. The difference is the way it's presented. All right, so let's try it out. Exercises 3.1 through 3.2. We're still using that same terminal window there. Go ahead and run exercises 3.1 and 3.2, which will now take DNSViz probe and try it out. So what we're going to do is run a probe of example.com. So you're going to be doing all those same queries you did with dig before, but DNSViz is going to do them for you and compile all the responses along with some meta information that's helpful for it into this JSON file, example.com.json. Okay, the $A says, don't query my recursive server, instead do an authoritative analysis. Go directly to the authoritative servers like we did before. Okay, and the $P means let's make it pretty so we can actually understand what we're looking at. All right, so go ahead and run those things, and then open, you can use mEdit. You can also use VI if you prefer, whatever text editor you're comfortable with. There's a couple installed on there. Sorry I didn't install Emacs because I would have had to add another 300 megabytes. Okay, DNSViz grok. Once you've got that probe output, okay, we're going to now process it. We're going to take all that raw information that we've just queried. For exercises 3.3 and 3.4, you're running DNSViz grok. You're still going to make the output pretty with that -p, and now you're going to input the output from the previous command, and you're now going to redirect that output to example.com-p.json. You could call these whatever, but I recommend you use the names that I've given for today's tutorial for consistency. And then go ahead and open that file when you're ready and take a look at it. Okay, we're now going to, and then we will walk through these in a little bit more, but I'm walking through the exercises and I'll give you a little bit of time to look at them yourselves and then walk through them. DNSViz grok has a couple options. One of them is kind of a priority level to show you only, for example, warning level and above, or only info level and above, so you can kind of vary the output that you're getting in this programmatic JSON serialized output. So in this case, we use the -L for log level info, and then again, we're making it pretty output with -p, and we're going to output it to example.com-p1, and you'll see a little bit different response because previously we didn't specify -L info, and it gave you all the information. It was giving you the content of the data and so forth. Okay, and then go ahead and open that one up and take a look at it. In 3.7 here, we're going to run DNSViz grok with the -L, with error supplied to the -L command line argument to then give you just the error level and above. And we're not redirecting it this time because hopefully you shouldn't get any errors, but I guess I don't know how example.com is faring today, so maybe you'll get something else. Now, since I mentioned that, I will tell you that you actually are going out to the example.com production servers with this, so you're actually doing an analysis as if your resolver were doing that and looking at it. All right, when you've had a chance to go through there, go ahead and go exercises 3.8 through 3.11, DNSViz graph. You're going to run this, and you're using HTML format. I told you there are several formats. The HTML format uses some JavaScript so that when you hover over, you can see certain JavaScript pop-ups, if you will, that will tell you a little bit more about different things you're seeing, different components in the graph. Okay, and you'll notice that I've asked you to do it twice. First time without a trust anchor, and the second time with a trust anchor, and that's to just learn a little bit more about what it means to actually have a trust anchor and what the output differences are in that. Okay. And then when you're ready, go ahead and open up Firefox with each of those and take a look at them. And then run DNSViz print, again without a trust anchor, and then finally with a trust anchor to see what the output looks like there. Those are exercises 3.12 to 3.13. So I know I've kind of talked through these. Who has done through exercise 313 is ready for me to start working through the results and just show you along with you what you should be looking at. Okay. Who needs a little bit more time to run through these? Okay. Questions while we're waiting on folks? And we're doing okay time-wise. I'm keeping an eye on the time, so don't feel rushed.
What happens if one of the servers isn't available to answer a query? Does that lead to a server failure? Does it guarantee that they are up, or does it create a chain?
Yeah, great question. So he asked, what happens if one of the servers isn't able to return a response? It's inaccessible for some reason. We're gonna synthesize that in our. So right now we're working in the real internet environment. In about 2 slides, we're going to change to the completely virtual environment, and we're going to break things, and you're going to see exactly what happens with that. We're going to break all sorts of stuff. So among which is that. Thank you for your question. All right, maybe just another show of hands for those that need another minute or so. Anyone? Okay, let's go ahead and start looking at some of the results then that you would see. So if we look at the DNSViz probe output, which is an example.com.json, this is the very top of the file, and you don't necessarily need to understand all of it, but you can see that it's a typical JSON file. You see there's the key on the left-hand side there starting at the root, because we've instructed it to say not just look at example.com, but also start all the way at the root. So you see root, and then you see all this meta information for root. So the type of analysis that we did was authoritative, meaning you were actually going to the authoritative server rather than recursive. That's important for later analysis to understand what type of responses you were expecting. Okay, some date information and so forth. You can see the mapping of names of authoritative servers to their addresses. Okay, this is important for later for offline analysis to understand what type of responses you think you should have gotten. Okay. You can see going down a little bit further in the file, that same file, you'll see that there are queries, a queries subcomponent to the analysis of, in this case, the root. So looking for the NS records, you're going to see responses, a response from each one of the servers that it queried in this list. Okay, and any type of meta information associated with it. Again, you'll see this a little bit later when we've thrown in some problems, so you can see what it looks like when things aren't clean and some servers aren't responsive. But this is for kind of a clean, if you will, analysis, what things would look like. Okay, and you can see some of the flags that were set in the requests under that options subcategory. And then some additional meta information. If you look further down, all the way down to example.com, you'll see some things in there like NX domain name. That was the software generated some type of name to send, hoping that it didn't exist, to try and elicit a negative proof from the server. Okay, those NSEC records that we were looking for earlier, that's why that's there. So it knows what name it queried to actually do that. Okay, there's some other meta information in there as well, but just so you can see that. Okay, so DNS Grok output looks a little bit different. It still has sections by name. In this case, you're looking at the section pertaining to the root name for that dot that's on the left-hand side towards the top. Okay, and in this case, we're looking at, first of all, the DNS key query associated with it. So you can see there's a description associated with it, a name, a time to live from the responses. And then DNSViz the Grok output is actually aggregating all the responses. So rather than show okay, this server returned this whole thing, and this server returned this whole thing. It's actually aggregating and saying this thing right here, which is the thing I'm talking about is the R data there, the 256, and then a bunch of blob and 257 and a big blob. That's the key material associated with it. And it's saying those servers down below in the server section all returned this same thing. So that's kind of a way of saying, okay, push it all together so we don't have to sift through all this stuff. Okay. If we move along a little bit further down, you'll see it also tells you a little bit about each DNS key. Each key individually and some of the components, components of that key. And it'll do that for every key there. And part of the reason it breaks it down this way, not just by DNS key set, but also by individual DNS keys, is because sometimes there are different servers serving different sets of keys, which is one of the problems that this is designed to help with. Okay, and then you can see here with the NSEC, you see the NSEC proof that has come back, okay, and querying for this name that doesn't exist, this RPH3TZ. You see a subcategory under there called proof, and under proof you see a set of NSEC records, okay, and it'll tell you whether or not it's valid. I'm trying to look for where the status is. It might be below. Well, there's a status section in there. I just don't see it at the moment. But it will tell you whether or not that proof was valid, because sometimes you get invalid proofs, and that's part of what's a little bit more difficult to do as a human analyzing it rather than a set of software analyzing something. Okay, so this is the info level update. You'll just see it has fewer fields. It's not showing you quite as much detail, but it'll boil things down to status, whether something was valid or not. Okay, but it won't necessarily give you all the values associated with this. So if I'm looking over on this site over here on your left, you'll see valid up here by status. That's the signature saying, yep, the signature was valid. Okay, and then same thing with the DS record over here again on the left. You can see that the status there was valid. Okay. Okay, so the whole point is to get some statuses. All right, but let's get a little bit more visual. This is a little bit more useful to pull out a graph. So this is the graph output without the trust anchor, and you can see that you see the blue in the arrows. The blue is good. It means that those signatures that the arrows represent are valid, and the hashes represented by the arrows are also valid. The outline color of the nodes themselves is black, which means that there is no trust anchor, it's not secure. But when you do the second output, you can see that it changes to kind of that bluish output, which means that they are now secure because you've anchored from a known trust anchor, and you've propagated the trust all the way down to the items that you're looking for, the resource record sets that you're looking for there. All right, so that is and then the double line at the very top indicates that is the trust anchor that you've selected, that when you put that -T on the command line, that corresponds to this key at the top here. And then finally, the two DNSViz print outputs are meant to show this. Yes, it's still a little noisy, but the point is it shows this entire chain as well, everything that you saw there, first of all in the insecure, and then later when you added the -T with the keys for kind of a blue color to show that what everything looks like when it's secure and that chain of trust is there. All right, questions before we move on to actually signing our own zone? Then let's get signing. Okay, so first thing we're going to do, we're going to set up a virtual DNS environment. So we're no longer going to be querying the real internet. We're going to create our own internet here. The entire thing. Well, the DNS anyway. Okay, so run this in your demo directory, run this command start all, and what it's going to do is start up 3 UML guests. That's user mode Linux. It's a kind of a lightweight virtual machine for this environment within that guest. And then for each one of those consoles that shows up on your machine, I'd like you to change directory to etc bind. Okay, so you should have 3 consoles come up, and let me show you what they're going to look like when everything's said and done. It's going to look like you're going to have this the host, you're going to have, sorry, the host is your laptop. The virtual guest box is the environment that you're running in, and then you're going to have this virtual switch with root 1, TLD1, and SLD1, okay? So that's your entire DNS hierarchy right there for what we're going to be working with. All right, so again, once your terminals come up, go ahead and change directory to etc bind in all 3 consoles. Otherwise, it will be difficult later on to get where we need to go. And then go ahead and change root, run this command, DNS change root, and you have to put that local in there, okay? All right. No, sorry, this, okay, let me be clear. Thank you for bringing that up. The cd etc bind is to be run in the terminals of root, TLD, and SLD, okay? The DNS change root local is run in the other window that you've been working in, okay? So this might be a little confusing, but you basically should have 4 windows up now. One of them is the terminal you've been working in, okay? That's the one that has the commands you've been running, and it's basically to the local machine, and then the other 3 are consoles to these other virtual servers, okay? All right, anyone need more time to get to this point? All right, so now let's go ahead and copy and paste this command, DNS probe -a. The reason why we're using this this -x option to DNSViz probe is because we're now going to specify the addresses. We're not going to the regular root anymore. We're going to this virtual root that we just created. Okay, so use that, and that's going to tell it to look everywhere inside, not to the outside anymore. Okay, this is run from your first terminal, not from one of your virtual server consoles. Okay, the demo directory, out of the demo directory. Thank you. Maybe I should colorize the prompts next time so that you can say, "Oh, this is the pink one." But I'm learning here, so. By the way, any feedback throughout this is welcome, either during or after as appropriate. I am interested in making this helpful to those that are here and not just fun to do. Okay, so when you've done that, you'll note that I've got, rather than doing this command over and over, there is a command, a simplified script for running this, DNSViz analyze, and that's just, it's basically the same script up above, but it runs it for you, so you don't have to type that long thing, okay, or paste that long thing for that matter. And then go ahead and run Firefox. Okay, so you'll see now that when you run the Firefox, you've created this graph. Okay, and it looks very similar to what we were looking at before, only example.com is no longer signed because this is our own example.com that we're going to play with now, okay, in our virtual environment. Does everyone see this? Anyone see something different? Okay, all right. Can we move along? All right, yes?
Question, in that graph, which part is virtualized and which part goes out to the internet? Where's the demarcation between the virtualized and
Great question. So where's the demarcation between what's going out to the internet and what is staying in our virtual environment? It is all staying in our virtual environment. We are no longer going out to the internet at all. Great question. Thank you. Okay, so this is our local root that we've just created. It's one of those consoles there that came up, is the local root server that provided these answers. All right. Okay, so now go to your terminal that's your virtual console for SLD1. So you should see a little prompt that says SLD1 there. And I need you to run these commands here. We're just going to change the zone so you have a little bit experience in manipulating a zone. So I need you to run all these commands 5.1 through 5.4. Again, you can paste these right into your console to make them quicker. Feel free to use VI instead of Nano. No Emacs. All right. Who needs more time? Okay. I'm rushing you, but don't feel rushed. Just kidding. For how many of you is this your first time manipulating a DNS zone? Okay. Right. All right. We about ready? Okay. Make sure your named check zone checks out okay, so we don't break anything because we need this zone to work. Okay. Now I've tried to change the prompts along the way so you can see which of these commands are supposed to be executed in the virtual console for the servers and which are supposed to be in your virtual guest. And typically that's with the pound sign versus the dollar sign. Okay. So sorry that's a little confusing, but bear with me here. All right, so here's what it looks like when you're adding. Should look something like this when you're adding records if you're using Nano. Okay, I did this because I didn't want you to have to learn VI if you don't know it. That tutorial is for another day. Okay, all right, and then you should get this response for whatever type of record you created. Anyone have any issues with that? Is it okay? All right, are we okay to move on? Do I need to move back one? Anyone? Okay, I'm kind of watching your eyes here, doing my best. Okay, we're going to go back to that console again. We're going to do exercises 6.1 and 6.3. Now that we've gotten this zone up, we've manipulated records, and we're now going to sign this zone. We're not going to sign the zone. First thing we're going to do is we're going to create two types of keys. Okay, so again, use your copy and paste because there's a lot of stuff in here. Feel free to manipulate it, but at your own risk. Okay, if you want to play around, that's fine, but use copy and paste here if you could to do these commands. Okay, so what we're doing is we're creating a key signing key. Remember, we talked about those that sign just the key set, and we're creating a zone signing key, and then we're also taking the output and storing them into a variable called KSK and a variable called ZSK so we can use them later without having to remember all the names associated with the files that came out of this. Okay, so this is, you can actually do, let's see, you can do all of through 6.9.1, I believe, with here, 6.9. Okay, so here's the second set. I want you to just take a look at the keys that you've created once you've done those commands. Okay, and then add them to the zone, and then go ahead and reload that zone. Then when you're going to do the reanalysis, do that again from the guest, not from the consoles. Okay, so you should see something like this for your output when you created your keys. This shows you the keys that were created. They're going to have different key IDs than mine, probably, although these are virtual machines, so who knows how good the entropy is. Okay, and then you'll see something like this when you cat the output of those files just to see what their contents contain. Okay, and when you run your reanalysis, it should look something like this. Who's not quite there yet? Okay. No worries. Do you need me to go back a slide, or are you okay? Okay. I'll just give you some time. For those of you that are finished, please take a look at the questions associated with the exercises. See if they make sense to you. See if you can answer them. I have no points and no rewards for you if you get them right, but you will get the satisfaction of knowing something a little more today. Thank you for the kind offer, Warren. We will not be giving the bent paperclip out as a surprise, as a prize. All right. How are we doing? Anyone still need more time? I see no hands going up. So either you're being shy or we're going okay to move on. Okay, so I'm showing the display output now for what our graph should look like. This is the state of our zone as currently, okay? Why do we have, well, first of all, what are we missing from this output? If you hover over, it'll give you a hint. And if you remember the previous graphs, something's missing in between those nodes. Signatures, sorry? Signatures, correct. Yep. The signatures, and those are, again, represented by arrows, are not there. DNSViz has made a guess as to where those nodes might fall if there were signatures. But you notice the outline of the nodes there is black, okay? Black means insecure. Remember that proof that we talked about, proof of a lack of DS record in the parent? To say we don't know anything about the authenticity of the child, okay? That proof is that NSEC box that you see there on your screen, the NSEC 3 box, excuse me, in this particular case. But all the proof says in this case is we know that there is no DS record, and here's the proof, and therefore everything below. So it doesn't matter how messed up everything is below because there is a proof that we don't know anything beyond .com. Okay, let's go on now and sign our zone. Now that we have keys in place and they're in the zone, we can now sign our zone. So, one more thing, you can just see that there's no AD bit from your resolver, okay, if you've done that step. But let's go ahead and sign records, okay, moving along here to get 7.1 to 7.4. Okay, we're going to sign our zone. So we're going back to the SLD1 console. Okay, so find your way to the SLD1 console to run exercises 7.1 through 7.3, and then 7.4 is done back from your guest terminal, okay, to do the reanalysis. So 7.1 through 7.3, we are going to, 7.1 is essentially just signing your zone, and it's creating a file. It's not overriding your existing zone file, it's creating a new one. So 7.2 is a simple little one-liner to change your named.conf file to point to the new signed file. That's all that's doing. And then finally, we need to reload it so that the running daemon knows that you've given it a new zone file. Okay, so those are those 3 steps. So paste those in, run those commands. Anyone need extra time with those 3? Okay, so you run your reanalysis there. Again, I hope you're using copy and paste as much as possible. And it should look something like this. Okay? Anyone see something different? Okay, good. What color are the outline of the nodes? On your own screen or on mine? They're still black. Why is that? Gabe? There's still no DS record, okay? Things look better. We don't have the same errors that we had, but remember, we don't have a secure link between example.com and .com. So let's fix that. We're going to go on to exercises 8 through 8.5. 8.1 through 8.5. Okay, it's still no AD bit. If you're querying a resolver, you're not getting that authenticated data because it's not authenticated. So let's add that link in our chain of trust and finish things up here. So we're going back to SLD1, exercises 8.1 and 8.2. We're going to do a little copy paste from your terminal. We're using that command DNSSEC ds from key with the $KSK. Okay, and that's going to give you the output. It's going to, remember I talked about the DNS key being a hash, or excuse me, the DS record being a hash of your DNS key. Well, that's what we're doing is generating the record associated with that hash, and then we're going to put it in the parent. Okay, so note that when you get to exercise 8.3, you've now copied those, but you need to move over to TLD1 console, not SLD anymore. So TLD1 holds the .com zone, so you need to go into TLD1, and that's where you're going to paste those records. So pay special attention to which one you're doing there. Everyone catch that? You're creating a relationship with your parent. Quality time with family is what we're doing here. Okay, so exercises 8.3 and 8.4 are to be done on TLD1, that is the COM server. So that's what we're doing here. And then finally, there's a little script that runs the re-signing, so you don't have to worry about those details. It'll take care of all that for you on TLD1. All right, run your reanalysis on your guest console, your guest terminal, and should look something like this. Just a quick check how folks are doing. Thumbs up, thumbs sideways, thumbs down in terms of keeping up. Okay, no worries. We'll give you a minute to get there. We're doing just fine on time, so take your time there and let me know how you're doing. If you need me to go back a slide for reference, that's okay too. This is just showing what's on your exercises.txt. Again, those who have completed those exercises through 8.5, go ahead and take a look at the questions along the way. Looks like there are a couple at the end there, and see, or if you've missed some of the previous questions. Anyone have any questions to ask me while we're letting people catch up here? Because we're going to start breaking some things next. But the point here is to understand some concepts related to DNSSEC maintenance, as well as how to identify them and hopefully how to fix them. Just checking in again, who needs a little bit more time? Anyone? Okay. All right, another 30 seconds or so, and we'll move on to the next section here and start having some more fun. If you can call this fun. That's right. All right, are we okay to move on? Okay, so you should see something like this now with anyone not have this graph. Did something go terribly wrong with your zone signing? Uh-oh. Were you saying yes because something did go wrong? Uh-oh. Shall I take 2 seconds to take a look? What's that? Oh. Did you run the re-sign TLD and that didn't work, huh? Did you do the reanalysis from your guest? And that didn't work either? Okay. Okay. All right, let me, so tell you what, why don't I move along a little bit? Is that all right? And then I'll check in with you in a little bit. Sorry about that. But actually, some of these will, so you're not picking up the new signed version of the TLD, is that right? So the DS record isn't picking up? Okay, anyone else having problems with that? Just to kind of get a couple data points? Okay. Warren's going to be my helper there, so I have another set of eyes. Thank you, Warren. Okay, I'm going to move along to section 9. And again, if any of you are not quite caught up, you can go back and just copy and paste these exercises right in. But we are right on time right now, so I'd like to continue going, and then we can catch some of anything that we may have missed along the way. Okay, so first thing we're going to do is just show a little bit of a bind tool feature here, and that is by default you're signing with you can notice in our example here, let me use the pointer here, you can see this little arc. So I'm looking on the left hand side, I'm showing this pointer just so you can see the arc. This is showing kind of a self-signature that it's signing itself. Well, this one has one too, meaning this key on the bottom, even though it's its own signing key, is also signing the key set. Now I don't have double arrows coming back up here for visual clarity, but it actually is signing both. So if you run this command 9.1 and then run 9.2 to reload the zone, you're actually going to see that this -X option makes it so that the zone signing key only signs the zone data and not the key data. So it's kind of just to show you a little bit of a nuance in both the tool, the analysis tool, as well as the bind DNS signing tool. Okay. Okay, and then go ahead and in 9.3 reanalyze. Okay, so let me move along here. And you'll notice when you've done that reanalysis that, oops, I've gone back a slide. You'll notice in that reanalysis you no longer have that arc. So you have just one signature covering the DNS key set rather than two, and that signature is made, in fact, by that key signing key. So you can see this signature made over here was actually not necessary because you already had a key. The purpose of the zone signing key is to be authenticated, not to authenticate other keys. Okay. All right. So 9.4 and 9.5. Let's actually run 9.4 through 9.8. It looks like, are the next section, and in there. We're going to add a new KSK. So we're going to add another key to our set that we already have. We have two. We have a key signing key and a zone signing key. Now we're adding another key signing key, and we're just going to throw it in there. So go ahead and follow these directions to generate a new one. Some of these commands are somewhat sensitive. Did that work? Okay. Okay, perfect. All right, so go ahead and you can just pipe through those next ones, just copy and paste them real quick. All right, so 9.4 through 9.8, you should now see a new key when you've gotten that far. Okay, which now it has, you see there are no arrows coming from it, which means it's not signing anything, it's just sitting in there. Okay, you might call this a standby key if you were doing this with some type of strategy, but it's just oftentimes we'll call this a published key. It's not actually doing anything. Okay, there might even be some metadata in what was in bind's output, I don't remember. But anyway, it's so-called published. Okay. So that is through 9.8. Let's go ahead and do 9.9 through 9.11. And we are now going to, let's see, where are we? Oh, we're going to sign the zone with that key. So we're now actually going to be signing with two keys. Excuse me, I'm trying to keep up with my slides and my notes over here and seeing which one is more accurate. Okay, so we got multiple KSK. So we now have that key that was published, and we're now going to be signing with it. Okay. We haven't broken anything yet, but don't worry, we will shortly. And for those of you who had to go, no worries. Go ahead and take the rest of those exercises. Just follow them through. The slides will be here if you want some additional reference. Okay, but the idea is it should be self-contained, so you can finish this later on, and hopefully it'll be useful. But no one else can leave, okay? All right. All right, so when you've done signing this again on SLD1, you should now see that key. Oops. Even with the instructions, I can't seem to get this clicker right. Okay, on the left-hand side now, you now see this key, but now it has an arc coming out of it. It is also signing, okay? All right, we have gone through there. Everything still looks good when you do your resolver output 2. You're still seeing the AD bit. That's good. That's all about to change. Okay, we now have a KSK signing the zone. We have a DS record corresponding to it. We're not going to change the KSK, which is signing the zone, okay? With these examples, 912 to 914. Hopefully this section goes a little bit quicker because you can kind of grab a bunch of text at once. For those of you not familiar with the terminal, you can even grab the stuff that has the pound signs at the beginning, and it'll just work those in as comments, and it won't actually execute them. So, okay, 912 to 914. So you're re-signing with the new KSK only, and then you're reloading your zone, and then run reanalysis. Who has done that and looked at the output? Okay. Who's still working on it? Who's reading their email? All right. Does it look like this? Okay, good. So what's wrong here? We're pointing to a key, right? And it's a valid key, right? It's not signing anything, right? So we have this DS record, and it is in fact pointing to a key, and the hash is correct, which is why the line between the DS and the DNS key is blue as opposed to red. But that key, nothing's coming from it. So if you were to follow these arrows all the way down, you couldn't go down all the way to the record sets that you need to sign. So in fact, everything below .com is broken. Now if you hover over some of those warning signs, now see all the signatures below are still correct, which is why the arrows are blue. Okay, but if you see that error symbol, that red symbol between the .com box and the example.com box, you hover over that and you'll see some of the errors associated with that. Okay, in particular that you don't have a DNS key signing that corresponds to the DS record. All right, things couldn't get much worse. Wait, yes they can. You'll also see that resolver returns serve fail. Okay, so that's what will happen if something is broken, or not even just because of maintenance, although that's what we've done is we've messed up things ourselves, but certainly if a bad guy is trying to do something and they break your chain of trust, that's the exact thing that DNSSEC was designed to stop. Unfortunately, if we're not maintaining things properly, it could look just as bad, which is why we're going through this training to show you some of the things that could happen so that they can be prevented. Okay, so let's make things a little bit worse. 915 through 917, we're going to modify the SOA record. So we're basically just changing that RNAME field in the SOA record using a quick sed command. But we're not going to re-sign the zone, which means what's going to happen to the signature associated with the SOA record? We've changed the content, but we didn't change the signature. Is it going to validate? No. Okay, and you should see that reflected now when you run that DNSViz analyze again, and then use Firefox to open it up. And you might say, well, everything looked broken before, so what's different about it? Well, go down to the SOA record and take a look in your box and hover over the arrow to the example.com, or if it's too hard to hover over the arrow, you can hover over the little error symbol near the arrow, okay? And that should show you that the cryptographic hash does not validate. the cryptographic signature does not validate. Okay? Anyone need more time there? Okay, let's move along. Let's do something else. Okay, going back to SLD1, we're going to run DNSSEC sign zone again. We're now going to set the expiration on the signature explicitly to 1 second from now. Okay, now some of you might be really fast and you might get over to do your analysis and everything will look just fine within that second. But I'm guessing most of you will have a different outcome. Be sure right after you sign the RSIG expiration, RSIG with the lesser expiration, that you also manipulate again that SOA record, because upon re-signing it's going to change it back and make everything look valid again. So go ahead and change that again, so we'll still have that same error propagated through there. Okay. And when you reload the zone and then do your reanalysis on your guest terminal, it will look something like this. Okay, anyone need more time? All right, so you can see kind of the use of colors that are designed in here to show you hopefully things that are problems that will jump out at you just by the color. Purple was actually meant to be expiration versus red, which is cryptographic signature problem. Although in this case, purple overrides red, because if you hover over the SOA record, you'll still see that first error that we put in there. As long as you reran that sed command again, it should show both the expiration and the cryptographic problem. Okay. And of course, we've got the problem with the DS pointing to the DNS key. So things couldn't get any worse until exercises 922 to 925, because we're going to remove a signature. This is what the bad guy might try to do if they're trying to make it so that you can't validate. They may strip the signatures in the response. Unfortunately, some middle boxes might do this too because they don't understand DNSSEC. Okay, so go on to SLD1 again, open up your .signed file, and we're going to remove some signatures. So if you look here, you can remove any signature that you want. Now you'll notice that these are done in multiple lines. Okay, and if you're using Nano, you can use Control-K to remove things. If you're using VI, then you should know how to do it. Okay. All right. Sorry. But what you'll see here is then you'll see the quad A record, and then immediately below it you'll see the NSEC record, because you've taken out that signature that would have been in there, okay, previously. That's all your work. Now, before you go any further, please run named checkzone to make sure you haven't messed up that that zone file, so that it will indeed load even in its bad state. Okay. And then run your reanalysis, and it should look something like this. And now, depending on where you removed the signature, and again I had, in the example, asked you to remove the quad A, the signature from the quad A record. So if you go down there, you'll note that there is no arrow going from the key to the quad A record. And there's also a little warning icon there on the quad A record. And if you hover over the quad A record, it should show you an error in the box there saying needs a signature or something like that, okay? Questions there? Now, again, I'll repeat, this isn't meant to overwhelm you. It's meant to show you some tools to help understand things that could go wrong and how to identify them. Although I'm leaving it as an exercise to the user as to how to fix these things. Because you can take this VM home and revert some of these things that we've broken. Anyone need more time here? Okay. So, modify TCP connectivity. True or false? DNS uses TCP. True. Doesn't use only TCP, but it does use TCP when necessary. Okay, and so we are going to do some. We're going to turn off TCP. This is on SLD 1, okay, exercises 926 to 927. You don't need to reload anything, just run the IP6 tables command, and then run your DNSViz analyze on your guest again. Rinse and repeat, okay? And this is kind of to demonstrate that DNSViz is actually going out and doing some work to test your TCP connectivity. If your packets get too big, then you may get what's called a truncated packet back over UDP, which means that you're going to require TCP. Okay? In this example, I don't know that we will, but at least you'll see the results from our test here. So if you look over here, you'll see a little kind of grayed out example.com SOA test that it did looking for TCP connectivity and a little warning icon above it. And if you hover over it, it'll tell you that it timed out or was refused. Your connection was refused because that's what we told it to do from SLD1. Okay? All right, shall we move along? Anyone need any more time there? All right. Now we're going to modify the path MTU. This IP tables command, this is for IPv4. We're going to drop UDP responses with payloads larger than 512 bytes because DNS operates with a maximum payload size of 512 bytes, right? Wrong. Okay. But there are some middle boxes that could inhibit packets larger than that from coming through, and they may not be within your control. And so it's good to know how you can diagnose this type of thing. And DNSViz in this case is actually trying a few different queries, getting some timeouts, and then dropping your max UDP payload size down to 512. And if it gets a response at that point, then it is assuming that is a problem with your PMTU. Okay? And so in this case now, the problem that it got responses with, something that you would expect a large response from, and we see two responses that had a problem with PMTU when we did that. Okay, those are the, I'm sorry for you on this side, but I'm just using the pointer on this side because it's where my right hand is. The DNS key has a little warning icon now over it, all the nodes do, because it detected that there was a problem with PMTU when retrieving the DNS key resource record set. Likewise, this non-existent name, in my case it was, I can't read it from here, okay, on the far right, that gibberish.example.com also has one. Why was that response so large that it had this problem? What else did it have in it besides the SOA record? It had the NSEC records and the signatures that went along with them, and those were enough to bump it up above that 512 limit. Okay, moving along, we're going to add a lame delegation. Okay, this gentleman over here had asked about that a little bit earlier. What happens if the DNS the server is not responsive? Okay, let's go to our TLD1. Okay, so not the SLD1 where we've been working. Go to your TLD1. We're going to open up the db.com zone file, and there's something in there that you're going to uncomment. Okay, because I've added it in there, but you just need to pull out the semicolon there. For example.com. b.local/sldservers.net. Okay, so if you look right above that, you'll see that in our delegation, we said, okay, from the COM server, we've established that for the example.com zone, there's one authoritative server, a.local/sldservers.net, which is our little virtual environment, okay? And then commented out, I had some other surprise ones that we're going to put down there, and that is b.local/sldservers.net. So if you uncover that, you notice we don't have another virtual machine running on that network. So what's going to happen when we try to query it? Are we going to get a response? No. Okay. So go ahead and run those commands. Run that resign TLD, and then run your reanalysis from your guest terminal. And it'll take a little bit longer because you'll notice it's trying hard to access this other server. It's trying actually under the hood a number of different diagnostics, trying to figure out if it's not responsive because of the path MTU problem that we just tried, or if it's a problem with something blocking eDNS, which is another DNS extension, or some other problem, okay? So it's incrementally trying these things, and then eventually coming to the determination that it just can't be reached. So now when you get to this graph output and you hover over the, again, this delegation arrow between the COM box and the example.com box, you'll see that warning icon. If you hover over that warning icon, you should see now the error that you previously saw about a DNS key not being signed, that corresponded to the DS record. But you also see a warning, a couple extra warnings in there. One about the NS record not matching. Okay. So something I didn't talk about earlier about DNS is that you have this delegation from your parent. You have these NS records that we just changed in the .com zone. Remember, that's the parent. But then there's also NS records in the child. They should match. They don't always, and sometimes there's a problem when they don't match. Usually it's that the zone administrator might make a change, and they'll change those NS records in the child, and they'll forget to change the parent, or vice versa. Okay, in our case, we've made a change to the parent. We've added a server in the parent zone, but we didn't actually have a server responding, so now we have two problems. There's a mismatch, but more importantly, the recursive resolvers are going to try to get there and fail. Okay, they won't reach it. So that brings me to the second icon down in the lower left. Near example.com, you'll see another little warning icon, and that shows you errors pertaining to the zone. You should see that it timed out trying to reach that server over UDP. And you also see the TCP error that we saw earlier trying to get the SOA record. Okay. All right. Any questions? Anyone need more time there? All right, then let's move along. Now you'll notice that we're getting kind of messy because we've added so many things to this, and there's lots to see, and it could be a little bit overwhelming, but you may be interested in just a subset here. So with 933, exercise 933, you'll see we're just graphing select R sets. We're using this -R, capital R option to do just A and quad A, and you could do whatever you wanted in there as long as it were in the analysis that you'd already done. Okay, and by the way, what you're using here is output that you'd collected from your last DNSViz probe in a file called example.com-working. Okay, and when you run that and then open that new file in Firefox, you'll see it's a little bit simpler. Hopefully easier to follow if you're just looking for select RR sets. Okay. And then if you run this thing, run this analysis using DNSViz print from that same file. Again, now we're taking the stored analysis. You're not actually going out and querying the servers anymore. You're just using the results of those queries, which are in the example.com-working.json file. And you're using DNSViz print, you'll see kind of a simplified output that shows you some of those same colors to show you where some problems are. So if you're just looking for kind of a quick result to see if there is a problem, you'll see it here in DNSViz print. Okay. Let's see. That is a duplicate slide. Okay, recursive server analysis. Now, up to this point, everyone here with me? Okay, up to this point, we've been looking at the authoritative servers. In this virtual environment, remember we have the client, which is the guest there. We have a recursive server running on it, and then we have these three virtual authoritative servers. Okay, I guess that's virtual. And you're doing the queries to those authoritative servers. Okay, but we can also query a recursive server. You might ask, well, why is this important if we're looking at, if we're wondering about a zone? Wouldn't it show up in the authoritative servers, and why would it matter if we're looking at the recursives? Well, this is where I say this is the recursive server. Your local recursive server is where the rubber hits the road. I mean, that's the stuff you're actually getting from your clients. That's, in fact, the most important thing that you can look at immediately, because that tells you if there's something wrong in your cache. Could be that it could be a misconfiguration associated with your authoritative servers. It could be that a malicious actor has actually injected something in there. Okay, and it could be something that is bad, but you can't see in the authoritative servers because of caching issues. If you take a snapshot of the authoritative servers at a given point, it looks fine, and then the next point they also look fine, but in between there they didn't allow enough time for caches to expire with the old records, for example. But if you look at your recursive server, you'll see that type of behavior because you're looking at that server that holds those records. So that's why we have the two types of analysis. You can either look at your recursive server or your authoritative servers. Okay, so just a quick couple commands with this recursive server analysis. Okay, you run DNSViz probe example.com. We're not using the -A option because by default it is going to use your locally configured recursive resolver. And then you pipe that directly to DNSViz graph, and this is what you get. Okay, you'll note this looks very similar to what you saw before. You'll probably also note it took a very long time to get it. Okay, because your recursive resolver, just like DNSViz probe, when it was trying to get out there, is actually trying to hit that other server with the lame delegation, and it's not getting there, and it's taking quite a while to time out, doing its own diagnostics. But that's the server now doing it, not the DNSViz software doing that. Okay, the one difference here between this graph and the one you saw before is you're not seeing, well, actually there are a couple differences, but you're not seeing the PMTU issues that you saw. Remember this non-existent domain, and also with the DNS keys. And that is because you're connecting to the this is an analysis going to your local recursive resolver now. So it didn't matter that there was a problem between the recursive resolver and the authoritative server, because this analysis is between you and the recursive, and between you and the recursive there wasn't that problem. You also won't see the delegation errors because you can't see those from the perspective of the recursive resolver. Okay, so just it's a little bit less output, even though there's still a lot there. All right, now this is great. It's useful for looking at to hopefully see some things to understand DNSSEC a little bit better in general, as well as providing some insight into what potential problems there might be with your DNSSEC deployment or with others' deployments. But it's not always feasible to expect a human to go and look at this output and understand it. And that's why there's this programmatic output. We talked about DNSViz grok, and we ran that with a good zone, example.com, and now we're going to look at it with the zone that we just had problems with. Actually, before we do DNSViz grok, we're going to look at the output of DNSViz probe. Again, somebody had asked earlier about what happens when you retry a server. So go ahead and open up example.com-working.json. This is our latest DNSViz probe output when we were hitting the authoritative servers, okay? Those virtual authoritative servers. If you scroll down a little ways, looking almost close to the bottom, you're looking for example.com section and looking for the DNS key query. Okay, so it should start something like this. So example.com qtype DNS key. You're going to see this under responses. You're going to see this history. Okay, and you'll see timeout and then action no change. This is actually showing the progression of what happened along the way when you were doing these queries and not getting responses. So you're seeing the actual diagnostics. So the first two times there was 1,000 milliseconds time elapsed, and we didn't do anything to change it because we just wanted to see if it was a problem with packet loss. Maybe things were bad with packet loss. But as things go down a little bit more, you'll see that after the third timeout and after 4 seconds of waiting, we actually changed the UDP, excuse me, not 4 seconds. We did 8 seconds of waiting and still not getting anything. We changed the UDP max payload size, and then we got a response back. Okay, and in fact, the response at that point had the truncate flag set, and so it told us to use TCP. So you can see this history of, it wasn't just a single thing that we did. It actually tried several different diagnostics, and all those are recorded in this meta information associated with the DNSViz probe output. So for so you can see why it made these assessments. As a system administrator, as a user, whatever, you can understand, how did it come to think that we had a PMTU problem? Well, it tried these things, and that's how it came to that determination. Because these aren't necessarily conclusive. It could have just coincided with some type of the server was down until right when you changed that, that setting, right? But it does some due diligence to try and avoid that. But here you've got the raw output. Okay, if you now exercises 10.3 and 10.4, if you run DNSViz grok again, so go ahead and just paste these couple commands in there and then open them up in medit or VI, whichever you feel more comfortable with. This working-p.json. You're now going to look at the DNSViz grok output of that same thing. And just to show you, again, we're using the -L warning level as opposed to the debug level. So we're getting some filtered, the output somewhat filtered and not too verbose. So you get, looking at this example.com, the A record, you get a status, the signature associated with it has status expired, okay, and it'll tell you a little bit more about that in the description field. And then there's a code if you want to, if you're doing this with some type of software that you want to parse, then there's a code there that you can rely on, as well as the description. Okay, you can see that it with one of the servers it timed out altogether. Okay, and that was that's the lame server that we set up that it couldn't access at all. Okay, and then this isn't well documented, but those query options down there tells you how you can essentially reproduce this problem if you're using some other tool. In this case, it's just a simple UDP query with no eDNS. And so you could use dig and pull that out to try and reproduce it. Okay, just the SOA record here, you can see those are expired. The signature is invalid. These are the errors we were seeing as you hovered over those nodes in the graph output. And then the TCP error, you can see that it was getting the econ refused error no message from the V6 only. Remember, we used IP6 tables, which means that only on the V6 version where we're seeing that, but the V4 version was okay. Okay, so just some additional items there in our output, DNSViz grok output. And then in this part, we're seeing the delegation status that will show up in there as well. All these corresponds to different parts in that graph you were seeing, but again, they have kind of a programmatic output. So if you were to create some client software to extract this information and make it more useful, then you can do that. But this is showing you that the delegation between com and example.com is bogus, and here are the errors associated with it, why it was bogus. Again, those same errors that you were seeing about the signatures were not found for the DNS key corresponding to the DS record. All right, this is. There are no scripts currently at least that I have written, that you can run on a regular basis to test things out. Here's kind of a sample script, except this one, I should say. Although this isn't in the DNSViz code, this is just something on a slide that if you want to take later and try and implement yourself in some variation, that's great. But the idea is, if you were to set up some type of monitoring on your zone once you set up DNSSEC, I hope you've not just set up monitoring, but also maintenance, like re-signing your signatures, so you don't have some of the problems we saw today. But this might be one way you do it, where you just you're doing a DNSViz probe of your name. Okay, you don't need to go all the way up to the root necessarily for your monitoring, just your stuff. It'll check your delegation, it'll check your UDP, TCP connectivity, your V4, your V6, all the things that we saw. And then when you run the DNSViz grok with a -warning level, it'll give you no output if there are no warning level and above, and so you can just go on your merry way. But if there is something, then it'll go send you a mail. It'll send you the graphical output. So anyway, this might be some example of how you might implement something like this. If you have something, some tweaks to this, or if you have something better, I'd be glad to see it. This is just kind of an example, something that might be useful. So, in summary, DNS and DNSSEC can be somewhat complex, as we've seen. Dig and bind and DNSViz and other tools can aid in both understanding as well as troubleshooting and maintaining and monitoring your zones. And hopefully DNSViz is also a way to combine some of the tools, the more fundamental tools underneath to make less legwork for monitoring some of these things, and hopefully that can be helpful to you. And of course, a reminder as you go practice this to monitor and maintain and set up things well based on some of the configuration errors that we saw today, so that those problems can be avoided in real life. DNSViz is available via a web interface at dnsviz.net. Okay, that's with a Z. And also there's a GitHub. This is open source. The current release is 0.5.0, which is the version that you've been using, and it's also it was released last week as a downloadable tarball from the GitHub site. There is a mailing list, but it doesn't have much activity, but you're welcome to use it. I am on there and we'll answer questions. Or you can just email me directly. So that's all I have. I'm glad to take questions in the remaining time, either about the tutorial itself or about the tool or anything we've seen today. Yes.
Internet Archive. I have this in production use, and what tripped me up in the beginning was the rotation, I think, of the zone signing key. I think there was like, the recommendation was make it last 4 weeks and then rotate every 2 weeks. Is that still a recommendation? Can you make a zone and sign it for 10 years and then just hope that there's no cryptographic attack on it?
So there are probably various feelings on this matter. I'll just say this here, the DNSSEC can be complex. And if you might have to judge for yourself and your team based on who's running it, how long they're going to be running it, what type of risk model you are with your actual DNS and what you're protecting behind it and so forth. Certainly the simplest is you can let a key run forever as long as you're re-signing the zone and making the signatures fresh. You could keep the same key in there, forever. And if you think about the jump from non-DNSSEC to DNSSEC, that's a pretty good jump. Okay, and rotating your keys is that much more. I'm not advocating that you don't roll your keys. What I am saying is that I think each individual and organization probably should decide what the risk is for their own maintenance and have a reasonable plan in place. But for whatever you do, test, right? And understand how it works well enough for your organization so that you don't get in a situation where things could break. That's kind of my 2 cents. Others may have different feelings, and you'll probably see that around. But yeah.
Hi, Dave Crocker. On the average, security procedures, including things like key management, are not that comfortable for average organizations to do. They don't have that much experience with it, and as you said, I thought it was fun that you said that this can be complicated, because that implies that there's cases in which it isn't, and I'm pretty sure there aren't any. As a consequence, I wonder about whether there is or could be at least some baseline recommendations for reasonable practice. I might even call it best, but then we'd get into the debate. But if a group doesn't have a lot of experience in this, it is almost certainly going to make the wrong choices. Having some guidance to set a baseline, which essentially says, this is pretty good. If you know what you're doing, go vary, as you want.
Yeah, so let me say 2 things about that. One, let me first of all reiterate what I said at the beginning. This was not meant to advocate that you do your signing like we did in this. This was more to get kind of dirty with things. But there are a lot of, don't reinvent the wheel. And there are a lot of tools out there, even Bind, we used at kind of the most basic levels here, but there's a lot of automated signing in Bind. If you use Bind, I know there are other tools out there as well, DNSSEC, several different flavors of things, and I'm just picking what's in my head right now, so I'm not trying to choose, saying you should choose these. But I guess what I'm saying is don't reinvent the wheel. There are other solutions out there. But I do recommend, even if you get some type of, for example, an appliance that does this with kind of a interface, that you understand what's going on under the hood, even if the kind of heavy lifting is done by the appliance. And I'm not going to talk vendors here, but there are appliances out there that do that, and I don't even have any recommendations because I haven't used any of them. But do you get what I'm saying here? That don't do all the stuff from scratch unless you. Well, just don't do anything from scratch, okay? Promise me. No, but do this if you want to play around with it and understand it, okay? But the second thing, there are some recommendations, Dave, out there. Probably the one I'm most familiar with is NIST's document, and I don't remember the number offhand, but if you look for like NIST, DNSSEC guidelines or something like that, there's some recommendations in there, and they have really good recommendations for defaults, and none of this is a hard requirement, but they're in there, and they show you procedures for things like these key rollovers that we've talked about, both ZSK rollovers and KSK rollovers. Okay, that's one example of document. Bind has put out, ISC has put out documents on maintaining your DNSSEC as well. So there are some good resources out there. And again, if you want to ask me, I can send some of them out to you directly. But those are a couple of them. The NIST one, the ISC one, and LNet Labs, it seems like has one. But I'm sorry, I don't have them on hand. But yeah, thank you.
Yeah,
Paul.
so Paul Rivers from Comcast. Just to comment on the key rollovers, while in theory the way you address the problem is depending on how many changes and how much exposed data, you decide whether that key is stale or not. The reality is that there's been a lot of discussion with the root key for the rollover, and the argument is if you never roll over your key and you never have practice and you never test your procedures, when you have to roll it in emergency, you're going to blow it. So the argument for regularly rolling your key is to validate that your procedures are safe and work.
Very good. Thank you for bringing that perspective, Paul. Yeah, I hadn't mentioned that earlier.
And Warren Kamari, Google, also following on with key rollovers, because they're the fun bits. That's where everything goes boom. There is an RFC, I think it's 7344 or something, which is supposed to make rolling your keys way easier. When your key rolls, basically the old key signs the new key, and the parent is supposed to go along and poll it and take that and actually start using it. So far, almost all of the DNSSEC outages have been key roll related. If people start implementing this, and some folk are, that should hopefully make DNSSEC have less of a bad reputation.
Right. Thank you, Warren. Thanks for that reference.
Hi. Thanks for presentation. And just a reminder for folks, RSA is not the only game in town. So I would encourage people to try the elliptical curve algorithms 13 and 14. I don't see Martin around here to advocate using Cloudflare with these, so I'm not going to do it for him, but I'm doing top-level domain administration for .ua, and we have not used this in production widely, but I'm sure there are other people who have tried. So are you supporting this in the tool? Because I know the online version does it.
It does.
Since last year.
You said it does support it, right? The online version?
I know the online does.
Yes.
Because I know Cloudflare pushed for that, so I said I don't
Yeah, and just
know
to actually,
if anybody was using this in larger production.
yeah, two quick comments on that. One, regarding the tutorial, you've got this VM. If you want to go play with it, do some more signing, you can use different algorithms, move in that DS record, move things around. It does support other algorithm types, including 1314, because this is a fairly recent version of Vine that's on here. And the second thing is DNSViz, the 0.5.0 release, has support for those algorithms, 13 and 14, but M2 Crypto, the library it depends on, is waiting for a patch that I contributed to be able to support those. So you have to patch M2 crypto if you're installing this from scratch. The next release will actually have them. Anyway, there's some documentation in there about that. If you're interested, read it, but those are just 2 quick points. Go ahead.
Yeah, thanks. Yes. So you're saying that the VMs that you host are supporting that, but just if you're going to build the code from scratch, then you have to patch the library first.
That's correct. I patched it on your VM, so it should support it just fine on the one on here. There's instructions on how to patch M2 crypto if you're putting it somewhere else, and you need that dependency of how to make that happen. And then as soon as the merge requests get into the next release of M2 crypto, then it'll just work, without having to patch it. But the patches are included with the DNSViz source to make that work. So,
Yeah, thanks.
sure. Thank you for the comment. All right. Anyone have any? You're welcome to come up to the mic or to just send me an email about what was useful about this or what could be done better for a future presentation. Either the slides or the presentation style or exercises, timing, whatever. So, thank you for your attendance and participation. I appreciate it.